Welcome back to my channel. In this video, we will solve a lead code question on trees. So it is a easy level question and it is called symmetric tree. So it says, given the root of a binary tree, check whether it is a mirror of itself. So it's saying there is a tree given and you have to check whether it is a mirror of itself. So if it take it from the center, so this whatever the left side sub tree is there, 2 3 4, and right side sub tree, it should be mirror to each other. So what is mirror? So if you stand in front of a mirror, how it will look? Your left will be right and your right will be left. So similarly here also you have to see that this subtree's left should be right and right should be left. So let's take this two left will be 3 here and it should be right of this right subtree. So here this nodes right 4 is left of the right subtree. So it's like just you flip this left side to the right side, whatever the result, the right tree should match with that. So if you see, this tree is symmetric because this 3 node which is left of this 2 node is to the right of this other side 2 node. So similarly this right node is the left of the other side node. Let's take second example. So if we consider this second node left is null and here the on the other side right should be null, but null right is not null, so it is not a symmetric tree. So here constraints we have to see and let's try to solve this. So it is very simple thing, we just have to know how to iterate this tree and we have to add that logic. So what I'll do, I'll just add a method. Let's take a method called isMirror, and what I'll do, I'll take two nodes as input. So let's take tree node root 1 comma tree node root 2. So let us return boolean from this. So initially what I'll do, I'm getting the root, so this root I'll get. So what I'll do, right, I'll take the left and right of this root and I'll pass it to this method. So I'll call this method, I'll say return is mirror of root dot left comma root dot right. So I've passed, this is root, I have passed the left node and the right node to this method. Now we are inside this method. Now we are at this left and right nodes. So what we will do, we'll write certain base cases. So what are those base cases? The base cases will be like, let's consider one node is null, another is not null. So in that case we have to return false. Otherwise, let's take this node is not null and the other node is null, then also we have to return false. If both of them are null, then we have to return true. So let's write the condition for that. If root 1 equal to null or root 2 equal to null, then what we have to return? Root 1 equal to root 2. So whatever the value will be there for that we have to return. So it means that if either of these nodes is null, we have to return false. If both of them are null, we have to return true. Okay. Now another condition, we have to check the values. If root 1 dot val not equal to root 2 dot val, so what we'll do, we will return false straight away. Okay, we will return the false. So these are two base cases. First we'll check this reference of these nodes, and then we'll check its value. Now what we can do, we can recursively do the same thing for every other node. Now what we have to do, we have to do the same for this node, this node, this node, and this node. So whatever two nodes we are passing here, right, these two nodes will just have to pass it here. So what we'll do, we'll say return is mirror of, what I'll say now, this left should be equal to this right. So I'll say root 1 dot left comma root 2 dot right, and there is one more condition. So we have passed this one root 1 dot left and root 2 dot right. Again this one root 1 dot right, let's take is mirror of, what we'll do, root 1 dot right comma root 2 dot left. Okay, root 1 dot left, root 2 dot right, root 1 dot right, root 2 dot left. Now let's try to debug this. Let's try to have a dry run and we'll see how it works. So let's take this input. So it is, we're passing the root. So root is 1 here. This node, we're calling this method here, root 1 dot left comma root dot left comma root dot right. So root dot left is 2, root dot right is 2. So these nodes we are passing here. We are checking root 1, root 2, either of them are null? No. So we are coming out from here, we are checking if root 1 dot value not equal to root dot value. No, it is equal. So we are not returning anything. Now we are coming inside, we are coming to this statement, return is mirror of root 1 dot left. Root 1 dot left is 3 comma root 2 dot right, so 3. So these two nodes we'll consider now. Again we'll go here with these two nodes. Here again we'll check either of them is null. No. Come to this root 1 dot val not equal to root 2 dot val, so they're equal. So again come here, again this, call this method is mirror of root 1 dot left null, root 2 dot right null. Again we'll come here, both of them are null, return true. Okay, next recursive call goes to the right side, is mirror of root 1 dot right and root 2 dot right. So again root 1 dot right, root 2 dot right, so both of them all return true. Again recursive calls come back to this part. Okay, it will come back to this part. It will say root 1 dot right is 4, root 2 dot left is 4. So it will take these two nodes. Okay, here again it will call, it will check if both of them are null or either of them are null. So no, so it will come here, it will check the values, both values are equal, so it will come here. Again this recursive call, right, it is for this one root 1 dot left and root 2 dot right. Similarly this one root 1 dot right and root 2 dot left, so null. So here it will come, both of them are null, so it will return true. So again finally, so whatever the value will be there, right, and value, if here at any point of time if anything is returned false, then the whole value will be false. So it will return the result finally. So let's try to run this. See, it's accepted. Let's try to submit. Right, so it is successfully submitted and it has taken 1 millisecond. And what is the time complexity? Time complexity is big O of n and space complexity is big O of 1, because we are using the same tree and we are not taking any extra tree. So I hope this you have liked this video. Please share with your friends and subscribe to my channel and press the bell icon. That's it from my end. Thank you.